we have studied earlier that if a wire is connected across the ends of a diode, then the potential difference across the two ends of the wire will be zero, as rather than the central depletion region, a new depletion region will be formed at the extreme ends of the semiconductor, such that the potential drop due to the central depletion region will get neutralized, giving potential drop across the two ends of the wire to be zero. Here we are going to find the open circuit voltage. Net current is equal to forward current, which is ideal diode current, minus optical current. We know that for a open circuit diode, the net current will be equal to 0. Also, forward current can be written as I0 exponential of. We have not applied any voltage in this case, but as we are supposed to find the open circuit voltage which is present on the two ends of the diode, therefore we will put the value of applied voltage in the expression of ideal diode current equation to be equal to open circuit voltage. This is the exact formula for finding the open circuit voltage which is caused due to the optical generation rate. You can see from this expression only that if there is no optical generation rate, then the open circuit voltage will be equal to So, it can be clearly observed that this open circuit voltage results only because of optical generation rate. If there are no photons incident on the semiconductor, then there will be no open circuit voltage. And the appearance of a forward voltage across an illuminated junction is known as photovoltaic effect. If we try to expand the expression for open circuit voltage, we can write optical generation rate to be equal to, similarly, reverse saturation current is equal to Now, if we consider a symmetrical junction, which means that the magnetic carrier concentration of holes in n-type is equal to magnetic carrier concentration of free electrons in the p-type. Also, magnetic carrier lifetime for free electrons and holes is equal. Therefore, for a symmetrical junction, we can find the value of thermal generation rate to be equal to magnetic carrier concentration divided by magnetic carrier lifetime. Now, if we replace this value in the open circuit voltage, we will get This was our first approximation. Now, second approximation we consider is the diffusion length of free electrons plus the diffusion length of holes is much greater than depletion width. By considering the second approximation, we can ignore the depletion width in the numerator of the expression such that the open circuit voltage expression will become Now, the third approximation is optical generation rate is significantly greater than thermal generation rate, which will give the open circuit voltage expression to be equal to This expression for open circuit voltage, which consists of so many approximations, is actually not important, but still you should be able to deal with such type of approximations when these cases are provided in the questions. By studying and practicing these type of approximations, you may be able to deal with a new type of approximation which might be provided to you in a question in the final exam. We got the formula for open circuit voltage, but open circuit voltage cannot increase indefinitely. The highest value it can achieve is the contact potential V0. Therefore, open circuit voltage is always smaller than or equal to contact potential V0.